Okay, for number three, common error is just to, dive in without thinking about it. But as we say, you really want to go through steps. And the first step I would look for, you might say I didn't do it in the first two problems. The first two problems are really very quite simple. But now I'm seeing there's a coefficient on the x squared term. And what I'd like to do is I'd like to factor it out. And it's factorable. And what I'm saying that 3 is common to all three terms. So it's going to be 3 times x squared minus x minus 2. Now, by the way, I'm left with something pretty simple, by the way. And so what are you left with? I'm left with a very simple quadratic, but the 3 is still there. I'm going to say x and x and 2 and 1. There's virtually no choice on it. And what I mean by that, no choice using finger numbers. X times x is x squared, 1 times 2 is 2. And looking at it, it appears to be this over here. Would I check it? Of course I would check it. Let me go through that with you. X times x is x squared. Then you get minus 2x plus x minus 2. What does this give you? 3 times x squared minus x minus 2. If you multiply that out, what do you get? 3x squared minus 3x minus 6, which is the original problem. What's correct factorization? This one over here. All right, I want to do the problem a little bit differently. And what I'm going to do over here is just, like if I wasn't thinking about it, I wrote it down. I'll write this over here for you. 3x squared minus 3x minus 6. And I already used the AC rule on it. Let me write A down for you. 3. The B, what's that going to be? Minus 3. And the C is going to be minus 6. So I'm going to write down A times C. It's called an AC rule for that reason. 3 times minus 6 is minus 18. What am I looking for? Two numbers that multiply to minus 18, but those same two numbers add up to the B number, which is minus 3. Well, looking at it, I'm going to say 6 and 3. Now, I didn't get the signs yet, though, but I'm going to say 6 and 3. What's it going to be? Minus 6 plus 3. Minus 6 plus 3. All right? Minus 6 times 3 is minus 18. Minus 6 plus 3 is minus 3. Then what do? I take this guy, I split it. So it's going to be 3x squared. Let's see. Let's put down minus 6x plus 3x. Again, I took the middle term. I broke it into two separate terms. Minus 6x plus 3x is minus 3x. And then minus 6 on the end. Going to factor by grouping. First two terms, 3x factors out. What are you left off with? X minus 2. On the second two terms, whoops, I went way too quickly there. Got to erase that. On the second two terms, a 3 factors out. And we left off with x minus 2. All right? Now, someone says, what are you looking at now? I'm looking at two terms, and I clearly see what's common between those two terms. 3 is common as a factor, and x minus 2 is common as a factor. What's left over? An x plus 3. Are we getting the same answer? Of course we're getting the same answer. What's the answer going to be? 3x plus 1. Made a mistake somewhere, didn't I? Oh yeah, I see it now. And I'm not going to redo it. I just made a really stupid mistake. And I'm gonna correct that right now. Sorry about that. But I'm glad I looked back at it and said that I made a mistake, though. Mistakes are easy. So let's put this down. So what's common? 3 is common, and x minus 2 is common. All right. I said there was something left over from the first guy. What's left from the first guy? Well, again, I want to emphasize, I factor out a 3, and I factor out x minus 2. What's left over? X is left over. Now, if I look at the second guy, I factored out a 3, and I factor in x minus 2. So what's left over? Just 1. All right. Of course you get the same answer. Let's go through that. You do get 3, x minus 2, x plus 1 in both cases. All right. What method do I prefer? I prefer like certainly what I'm really most familiar with, which is basically GCF factorizations, looking for something simple to do with trial and error. But again, the AC rule works nicely too. Really does. Thank you.